Hi, welcome to Computing Foundations. This is a channel for beginners who want to learn about computers, programming, and the math, science, and art behind this world-changing field. I'm Josh Kilpatrick, a retired software engineer. Today we're continuing our journey learning the C programming language, and today's topic is multi-dimensional arrays. That's a mouthful, but let's dive in and understand this important topic. So what is a multi-dimensional array? First, let me start with explaining this by giving you an example of something that would be difficult to accomplish in the C language with only the tools we know about today. So imagine if we go back to my example that I had several videos back about a game played between two teams where each team has 9 total periods and a score for each period. This is how the scoring for American baseball works. Two teams play and there are 9 innings. In each inning, each team has an opportunity to bat, to hit the ball, and to score points. So we looked at how we could use an array to store the points for each team. Each team would have one array that would represent 9 different scores for the game. But what if we had 2 games? If we needed to keep track of 2 games that were going to occur, say, over the course of a weekend? Well, with the tools we have today, we'd need to define 4 arrays. And we could name each array based on the team and the game. So team 1, game 1, an array of 9 integers. Team 1, game 2, an array of 9 integers. Team 2, game 1, etc. Well, imagine if we had like a weekend tournament where we were going to play 6 games. Now we have to have 12 different array variables to keep track of all the scores. So we've kind of ended up back in the same place where we started before we knew about arrays. Sometimes we might need many arrays, which is pretty inconvenient. What do we do about that? Well, enter the concept of a multi-dimensional array. So here I have defined a multi-dimensional array called scores. Here's what the definition looks like. We have dimensions in brackets, but instead of just having 1 dimension, we have 3 in this case. So in this example, perhaps I'm going to use the first dimension to represent the 2 teams. The second dimension represents 2 games, game 1, game 2. The third dimension represents the innings. Each game has 9 innings. So working in reverse, we could say there are 9 innings per game. We will play 2 games. There is 1 game per team, and there are 2 teams. The way that I said that doesn't really work out the way that I expected it to in an English sentence, but I think you understand what I'm getting at. So one way to think about a 2-dimensional array, or to think about a multi-dimensional array, is to think of it like a table or a spreadsheet. So let's take a look at this example. Imagine I had a spreadsheet or a table, and it had 5 total rows and 4 total columns. So if my definition of the table is 5 by 4, then what I'm saying is 5 rows, and each row has 4 columns. So if I wanted to reference data in this particular element, I would say row 1, column 1. If I wanted this element here, I would say row 2, column 2. So we can think of this 2-dimensional array almost like we're working with a spreadsheet, and the first index tells us what row, and the second index tells us which column we want to access. in a similar kind of geographic or geometrical example, we might think of a three-dimensional array something like a cube, where the first dimension tells us how many rows to go up, the second dimension tells us how many columns to go over, and the third dimension sort of situates us in space. Imagine we have several different tables sort of sitting one in front of the other in aisles. And I can say, not only can I pick a row and a column, but I can kind of pick which aisle, which table do I want to access. This is how we might think of a three-dimensional array, where there's a row, a column, and an aisle. There's a bunch of different tables. Well, we can continue adding more and more dimensions to our arrays, but after we get past 3 dimensions, thinking about it as a geometrical shape doesn't really make sense anymore. It begins to break down. I can't draw an image of data in 4 dimensions. But let me give you another example that might help you visualize what an array of greater than 3 dimensions might mean. So imagine we were looking at a report of jobs by the U.S. Labor Department. And every month, the Labor Department releases a report that says how many jobs were added to the economy in the last month. Well, we might think of it in terms of the report has different dimensions along which it reports the data. So instead of just reporting how many jobs were added to the economy overall, they say how many jobs were added by state, the gender, male or female, of the employee, and age, the age of the employee. So in this sense, we might be able to represent the data using a 4-dimensional array, where I would say, okay, there are 12 months in the year, so I have 1 dimension for the month of the year. There are 50 states, so I have a dimension of 50 elements to pick the state. There are 3 different genders, male, female, and non-gender conforming or non-binary. So 3 genders. And there are, let's say we're going to track people from 0 years old all the way to 100 years old. So in this way, if I wanted to say, what is the data for January? Well, I would put a 0 here. What's the data for Alabama? Making this up, but let's imagine Alabama was represented by 0. So we'd say 0 here. And let's say males are represented by 0. So we'd put a 0 here. And then I would say people of the age 25, I would put a 25 here. So I can think of this multi-dimensional array as being different specific attributes about a piece of data. That might be a useful way to think about it. Okay, how do we initialize one of these multi-dimensional arrays? It's pretty straightforward. We define our array with its rows and columns, and then we open a curly bracket, just like we did for single-dimensional arrays, except instead of immediately putting the values between the first 2 curly brackets, I have 2 additional sets of curly brackets that represent each row of the data that I want to set into this array. So this is an example of setting up and initializing a 2-dimensional array with 2 rows and 4 columns. Pretty straightforward. Well, one slightly weird thing that I need to make you aware of with regard to multidimensional arrays is that when we want to pass a multidimensional array as a parameter to a function, we have to define it like this. So we have to say how large is the dimension for every dimension except for the first dimension. This dimension can be variable. It doesn't matter what dimension of the array we pass into the function, but the other dimensions must be specified and specific. Let's try to think a little bit about why that would be. Well, if I pass into print scores an array, if I've defined that the second dimension is 4 long, here's kind of how it would look in memory. So the first memory slot for scores 0 sub 0 is here. And then all the way we go from 0 sub 0, 0 sub 1, 0, 2, 0, 3. Each of these are lined up one after the other in memory. And then finally, after we do 4 elements, we get to the next row of data, which is scores 1. And we begin with 1, 0, 1, 1, 1, 2, 1, 3. Okay, so to make my point, if we don't tell the function how wide the rows are, how many columns are in the rows, it doesn't know how far to skip ahead in memory when I ask it for, how wide are the columns, how many columns do I have? It doesn't know how far to jump in memory when I ask it to go to the second row. So the first row begins here. That's the beginning array of the address. But where does the second row begin? The only way to know is to know how wide are the rows, how many columns are there in the rows. So we must, when we write a function, describe the dimensions of the size of all the dimensions except for the first dimension of the array. All right, that concludes what I wanted to tell you about multidimensional arrays, but this is a great spot to stop and have another challenge. So now we have just enough information. We've learned about arrays, we've learned about strings, we've learned about multidimensional arrays. We can do something interesting now with all of these 3 different types of data. I want you to write a program that will represent a phone book. Here are the rules. The phone book must hold 100 entries. Each entry consists of a name with 2 parts. The first name, which must be less than or equal to 15 characters, and the last name, which must be less than or equal to 20 characters. I want you to store the first name and the last name separately. They're independent strings. Then we have another field for each entry called the phone number. It must be less than or equal to 16 characters. The program is going to support actually 3 commands. I said 2, but I meant 3 here. 3 commands. The first, if the user enters an A, then it will enter into a process of adding a new entry to the phone book. So the user can enter in first name, last name, and a phone number, and then the entry gets added to the phone book. The other command we'll accept will be D for, hey, display the phone book. And the final command will be Q for quit, exit out of the program. So when you run your program, the program will start up and print to the screen, hey, welcome to the phone book. If you want to add an entry, press A. If you want to display the entire phone book, press D. If you want to quit the phone book, press Q. And the user can say A, D, or Q. If they say A, they're going to get prompted to enter in first name, last name, phone number. If they say D, we're going to go through the phone book and print out all the entries, names and phone numbers. First name, last name, phone number. Finally, if the user presses quit, we're just going to exit out of the main program. So this is a challenge that I think will give you great experience with reading and writing strings, and will also force you to get comfortable with multidimensional arrays. So good luck, and we'll see you in the next video.